The problem caused by hidden actions is called moral hazard, and we will analyze this problem using the principal-agent relationship. In this example, Paul, the principal, owns many ice cream parlors across North America, and he contracts with Amy, the agent, to manage his Miami shop. Amy is basically the manager for Paul's Miami ice cream shop. Amy and Paul have different risk preferences. Paul is risk neutral because he can pull returns from many stores he owns. Amy is just a manager work at a store, and she doesn't have all the resources or income sources like Paul. So naturally, Amy, like most people, is risk averse. The earnings of the ice cream shop depends both on the demand, which is a risky event, and Amy's effort level. Each day, the demand can be low or high, and Amy can exert an effort level of normal or extra. If Amy works extra hard, it will cost Amy $40 for this extra effort. Each day, the demand can be either low with 50% of probability or high with another 50% probability. So if Amy just works at the normal effort level, if the demand is low, then the shop receives $100. If the demand is high, then the shop receives $300. But if Amy is working extra hard, if the demand is low, the shop receives $300, and if the demand is high, the shop receives $500. When there is asymmetric information or hidden action, that means when Amy's effort level is not observable to Paul, this set of payoffs can be problematic because the earning from low demand and Amy works extra hard equals the earnings from high demand and Amy works at a normal level of effort. Because Paul cannot observe Amy's effort level, Amy can always blame the demand is low and claim that she is working extra hard. So the same amount of $300 when Amy's effort level is normal and the demand is high, and when Amy's effort level is extra hard and the demand is low, combined with the fact that Amy's effort level can be a hidden action, that caused the problem of moral hazard. To manage this principal-agent relationship, Amy and Paul can set up various ways to split the earnings from the ice cream shop through different kinds of contracts. And what we are looking for is an efficient contract for them. That means in this contract, neither party can be made better off without harming the other party. In our setting, because at least one party, the principal Paul, is risk neutral, we require an efficient contract that can maximize the combined earnings or the joint earnings for both parties. This efficient contract also considers the risk allocation between parties. Basically, we want the risk-neutral party to bear all of the risk if the other party is risk-averse. That means we would like to see the variance of Paul's earnings to be higher than that of Amy's. To start our discussion, we first look at when the information is symmetric, and we consider a fixed salary contract. Under this contract, Paul pays $200 to Amy if and only if Amy works extra hard every day. Because Paul pays Amy a fixed-rate wage, Paul will be the residual claimant. That means Paul receives all the residual earnings from the ice cream shop. There is no hidden information here because we assume that Paul can perform this perfect monitoring. Paul knows whether Amy works extra hard or just at the normal level. Let's look at Amy's effort level choice under this contract first. So if Amy chooses to work at the normal level, Amy will receive $200 per day. and that wage is fixed, so the expected wage is $200, and the variance for Amy's income is just 0. However, that is not the effort level Paul will allow, so if Amy just works at the normal effort level, she will be fired. The result is that she has to choose the extra hard level. By working extra hard, Amy received only $160 because when she works hard, she has to deduct this cost of effort $40 from the $200. Again, because the salary is fixed, so each day Amy just receives $160 and the variance is still 0. When Amy works extra hard every day and when the demand is low, Paul receives the gross earning of the $300 minus what he pays to Amy and get this residual earning of $100. When the demand is high, the gross earning is $500 for the ice cream shop, and Paul pays Amy $200, so the residual earning to Paul is $300. So for Paul, there is 50% of chance to get $100 and another 50% chance to get $300. The expected net earning is $200. That is the probability-weighted average earnings. We can use this function for population variance to calculate the variance of Paul's earnings, this VARP. Because this $100 earning and the $300 earning has equal probability to occur at 50%, and these two are the only two possible outcomes. These two outcomes is the population for Paul's earnings distribution. So we can apply this VARP directly onto these two outcomes, and we find that the variance of Paul's earnings is 10,000. This contract is efficient because the joint earnings is $360. And Paul, the risk-neutral party, the principal, bears all the risks. Amy bears no risk as the risk-averse agent because her earning variance is 0. And Paul bears all the risks because the variance of his earnings is 10,000. The 360 is the maximum possible joint earning because the gross expected earning when Amy works at a normal level of effort is just $200, and the gross expected earning when Amy works extra hard is $400. But if Amy works extra hard, she needs to pay a $40 cost. So the net combined gross earning is $360. And the variance for the two effort levels by Amy is the same, 10,000. This 10,000 is exactly all borne by Paul under this contract. So we can see that when the information is symmetric, this fixed salary with perfect monitoring can result in an efficient contract. The joint earnings are maximized and the risk-neutral party bears all the risk. The risk-averse party bears no risk. Next, let's consider when there's asymmetric information. Now, Amy's effort level can no longer be observed by Paul, and we still assume a fixed fee contract. That means Paul pays a fixed wage of $100 per day to Amy and let Amy operate his ice cream parlor. We still first look at Amy's effort level choice. With normal effort level, Amy receives $100 per day for either high demand or low demand. So the expected value of her income is $100 and there's no variance. However, if Amy works extra hard, she will have to bear the $40 cost for working extra hard. That is this green cell here. So for either high demand or low demand, Amy only receives $60 per day. And of course, the expected value will be $60 per day for her income, and the variance is still 0. Now, because this effort level is no longer observable, in other words, Paul cannot set the pay conditional upon Amy's effort level anymore. The result is Amy will choose the normal effort level, which costs her nothing. Next, let's look at what happens to Paul's income when Amy just works at the normal effort level. When the demand is low, the revenue from the ice cream shop is just $100, and this $100 is paid to Amy, so Paul receives 0 residual earnings. And when the demand is high, and Amy is working at the normal effort level, the ice cream shop receives $300 per day, and Paul needs to pay $100 to Amy, so Paul gets $200 left. There is 50% of chance for Paul to get $0 per day, and another 50% of chance for Paul to get $200 per day, so the expected value is just $100. And the variance is still 10,000. Now, the risk allocation is correct between the risk-averse agent and the risk-neutral principal, because Amy bears no risk and Paul bears all the risk. But the combined earning is just $200 because Amy is working at the normal effort level, and the gross earning from this ice cream shop is just $200. $100 is paid to Amy, and Paul takes the $100 left. Now, because the joint earning is no longer maximized, this contract is not efficient, and that's come from the fact that Amy's effort level is not observable to Paul. In other words, hidden action is causing inefficiency in this relationship. You may wonder what happens if Paul sets higher salary. Let's say this compensation for Amy here, the green numbers, is $200. I put $200 in, and let's see what happens. This is the same pay as when we have the symmetric information, as when Paul can perfectly observe Amy's effort level. Now, Amy just earned $200 with no variance, but Paul's income falls to negative $100 if the demand is low, and he earns $100 that is left after paying Amy $200 if the demand is high, and the ice cream shop receives $300. The expected value of Paul's earning now is just 0, because Amy takes all these gross combined earnings, and Paul still faces this variance of 10,000. So as long as there is hidden action, which means Amy's effort level is not observable, and it costs Amy to exert this extra hard effort level, Amy will always choose the normal effort level, and this fixed wage contract is always inefficient when there is this hidden action. Since under asymmetric information, when there is hidden action or the hidden effort level chosen by Amy, the fixed wage contract is no longer efficient. Let's consider some other contracts to see whether the efficiency can be improved. The first contract we are going to consider is this fixed license fee contract. So here, instead of Paul paying Amy a fixed rate, Amy pays Paul a fixed rate of $200 each day for operating this ice cream shop. And then Amy becomes the residual claimant. Amy gets to keep whatever left after $200 is paid to Paul. So one result that is easy to observe is the fact that now Paul becomes this fixed income earner, so his expected value of earnings is $200 fixed, and he bears no risk because the variance for his income is 0. Let's go back to look at Amy's effort level choice. If Amy works at the normal effort level, she will receive net earning of negative $100 when the demand is low because there's only $100 earning to the shop and she needs to pay $200 to Paul. If the demand is high, $300 received by the shop and she pays $200 to Paul, Amy receives $100 left. The expected value for Amy's income when she works at the normal effort level is 0, but the variance is 10,000. However, if Amy chooses to work extra hard, when the demand is low, she will get $60 left. That is $300 revenue by the ice cream shop, and she pays $200 out of that $300. On top of that, there is $40 effort cost. So she got $60 left. But if demand level is high, the gross revenue to the shop is $500. She pays $200 to Paul and bears $40 effort cost. She got $260 left for herself. The expected value of Amy's income is $160 when she works at the extra hard level, but the variance is still 10,000. So when Amy pays this fixed fee, $200 to Paul, the combined earning is $360, which is at its maximum level. But now Amy bears all the risk. The variance for Amy's income is 10,000. Based on our original assumption that Amy is risk-averse, this risk allocation is not efficient. So even though this fixed license fee contract provides the maximum possible joint earnings to both parties, the risk is not allocated to the risk-neutral party in this contract. That means this contract is still not efficient. So between this fixed license fee contract and the fixed wage of $100 per day, if Amy is risk neutral, she may actually prefer this fixed license fee contract. But if Amy is very risk averse, she may just prefer this $100 per day fixed wage contract. So whether Amy prefers to be the residual claimant really depends on her risk attitude. The next three contracts we are going to consider are so-called contingent contract. One is the state-contingent contract, and the second one is the profit-sharing contract. The third is the contract with a bonus. In this state-contingent contract, the state of the nature has to be verifiable. That means both Paul and Amy have to be able to agree upon the state of nature, whether the demand is low or high. So the license fee paid to Paul can be contracted upon the demand condition. If the demand is low, Amy pays $100 to Paul. And if the demand is high, Amy pays $300 to Paul. Let's again look at Amy's effort level choice first. If Amy chooses to work at the normal effort level, Amy will receive 0 if the demand is low because the gross earnings to the shop is $100 and she pays out $100 to Paul. And when the demand is high, Amy's income is still 0 because the gross income to the shop is just $300, which is what she needs to pay Paul when the demand is high. So the expected value for Amy's income when she works at the normal effort level is just 0, so is the variance. Now, if Amy chooses to work extra hard, she will be able to receive $160 after she pays Paul $100 out of the $300 gross earning to the shop. And she also pays $40 for her effort, so she has $160 left. When the demand is high, she also got $160 left because now the gross earning to the shop is $500. She pays $300 to Paul, then she got $200 left, minus the $40 cost for her effort. She has $160 left. Now, the expected value for these two $160 is $160, and the variance for Amy's income is 0. Now, we only need to consider Paul's earnings when Amy is working extra hard, because the license fee paid by Amy to Paul doesn't depend on Amy's effort level, but it depends on the realized demand. So whether Amy works extra hard or just at the normal level doesn't influence Paul's earning. The results are the same for Amy's effort level choice. So if the demand is low, Paul receives $100, and if the demand is high, Paul receives $300. The expected earnings for Paul is $200, and the variance is $10,000. Now, this state-contingent contract gives us a combined earning of $360. That is the maximum possible amount, and this $10,000 variance is borne completely by Paul, and Amy bears no risk. So this state-contingent contract is efficient. In other words, this contract solves the moral hazard problem in this principal-agent relationship. But it does depend on the fact that both parties can agree upon the realized demand level. In other words, if this state of nature, the realized demand level, is not observable, or the parties cannot agree upon these two states, or the state of the demand cannot be verified by a third party, it is impossible to implement the state-contingent contract, and there's still no solution to the moral hazard problem. Next, let's consider profit sharing. Paul and Amy shares the profit 50-50. They each take a half of the total gross earnings. Let's look at Amy's effort level choice first. So if Amy works at the normal effort level, she will take $50 out of the $100 if the demand is low, and she will take $150 out of the $300 if the demand is high. So the expected value of her income is $100, and the variance is $2,500. Now let's consider when Amy chooses to work extra hard. If the demand is low, she takes the half of $300, that is $150, and she needs to pay this $40 for extra effort, so she gets $110 left. If the demand is high, she takes a half of that, which is $250, out of which she will pay the $40 for her extra effort. She gets $210 left. The expected value of Amy's income is $160 for this level of effort, and the variance is $2,500 as well. So now, between the two effort levels, one provides a higher expected value, and they have the same level of risks. So Amy will choose to work extra hard. Now, based on Amy's choice of effort level, Paul will receive $150 when the demand is low, which is 50% of the $300, and he will receive $250 when the demand is high, which is 50% of this $500. The expected value of Paul's earnings is $200, and the variance is $2,500 as well. So now we can see that under this profit-sharing contract, the combined earnings for both the principal and the agent is maximized at $360 per day. But both Amy and Paul bear some risk. However, given the possible effort choices by Amy, she doesn't mind work extra hard and bears this risk just because the other choice of effort level gives her the same amount of risk, but lower expected income. Let's consider another situation if we set Amy's share of profit to 15%. So we put 15% here and 15% here. What we can see is that if Amy takes only 15% and Paul takes 85%, Amy's expected earnings is actually higher when she chooses the normal effort level. And that will lower Paul's expected earnings as well. So even Paul has a higher share, the joint earnings is no longer 360, but 170 plus 30, that's 200. The joint earnings is no longer maximized. So the profit sharing at 15% to 85% between Amy and Paul is no longer efficient. This tells us for the profit sharing contract to work, the agent's share of profit need to be high enough so that the agent will work extra hard. If the profit share for the agent is not high enough, the profit sharing cannot guarantee that the agent will act in the best interests of the principal. At last, let's look at this contract of fixed wage plus a bonus. The bonus is only given to Amy if the revenue to the ice cream shop is above $300. In our setup, it means that only if the revenue to the ice cream shop is $500, Amy will receive this $200 bonus. Otherwise, Amy just received this $100 fixed wage. Now again, let's look at Amy's expected income and the risk involved for her choices of different effort levels. If Amy works at the normal effort level, she will just receive this $100 with an expected value of $100, and the variance is 0. She bears no risks. Given that choice of effort level by Amy, Paul's expected earning will be $100 because when the demand level is low, this $100 gross revenue to the shop goes completely to Amy, and when the demand is high, $100 out of the $300 revenue to the shop goes to Amy, and Paul receives $200. So the expected value for Paul's earning when Amy works at the normal effort level is 100, and the variance is 10,000. If Amy chooses to work extra hard, she will receive $60 if the demand is low, because out of this $300 revenue to the shop under low demand, she only received $100, but she also needs to pay the $40 cost for her extra effort. But when the demand is high, she can receive this additional bonus of $200. This $200 add on top of this $60, she will receive $260. That's $300, the base salary $100 plus the $200 minus $40 for her extra effort. The expected value of Amy's income when she works extra hard is $160 in this situation, and the variance is 10,000. For Paul, he will receive $200, that's $300 minus $100 when the demand is low, and another $200 when the demand is high because he needs to pay Amy $300 in total for the base salary plus the bonus out of this $500 gross shop revenue, and he gets $200 left. In this case, the expected value for Paul's earning is $200, and the variance is 0. So the efficiency of the bonus contract really depends on Amy's risk attitude. If Amy is risk neutral or nearly risk neutral, she will choose to work extra hard and bear this risk in order to receive a higher expected income. But if Amy is very risk averse, she would rather just have this $100 for sure and bears no risk. But under that situation, the expected combined earning is just $200. This $100 for Amy plus this $100 for Paul. So the bonus contract is not efficient when Amy is very risk averse, even though the risk allocation is efficient. That means Paul bears all the risk of this 10,000 and Amy bears no risk. So this base salary plus bonus contract will be efficient only if Amy is risk neutral Under that assumption, the joint earnings is maximized, and the risk allocation is fine just because Amy doesn't really care this 10,000 variance. So what we have seen is that for an incentive contract to be able to resolve this problem of moral hazard, each contract needs some necessary conditions so that it can work. For the fixed license fee contract to work, the agent must be risk neutral. For the state-contingent license fee contract to work, the state of the nature has to be verifiable, observable, and agreed upon by both parties in the contract. For the profit-sharing contract to work, the agent's profit share has to be high enough to induce the high effort level. For the fixed salary plus a bonus contract to work, again, we have to assume that the agent is risk neutral. So when there are hidden actions involved in a transaction, the manager has to consider the contracting environment and the risk attitudes of all the parties involved in order to design an incentive contract that is efficient to induce the best behavior by all the parties.